Okay, now what we're going to be able to do is graph a parametric equation, and we're going to use our calculator at the same time, so go ahead and get your calculators out. So we have an x equation in terms of t and another y equation in terms of t, and we're only going to look at this graph from t values from negative t to 3. Okay, so the first thing we're going to do is we're going to just go ahead and look at a table of values. So I'm going to create a table of values for all my t values, and I'm just going to look at a couple. So we're going to start at -2, we'll do -1, 0, and obviously we can create as many values as you want, and then we want to find the corresponding x and y values. So all we're doing is taking the t, plugging in here to find the matching x value, taking the -2, plugging in here to find the matching y value. So you can do this for every single value. You can also find this on the calculator. So go to your calculator. You want to make sure, so the only time you want to really be in parametric mode is when you're looking at the graph and when you're calculating the slope sometimes. So right now you probably have this in function mode. We want to move over and highlight the parametric mode and press enter. Okay, and again, always make sure that you're in radian. Now when you go back to your y equals, instead of y, you will get an x and a y of t. So it tells you what's the first x of t equation. So I'm going to plug in t squared minus 4, so notice when I use this button it'll automatically just give me the t. T squared minus 4. My second equation is t divided by 2. So go ahead and type in your equation, and before I look at the graph it does give me bounds for my t, so let's go ahead and set that up. So your t, I want it to go from -2 to 3 for this particular graph. Now your t step is how many points do you want it to graph? If you only go up by 1, that's fine. It'll graph from -2, -1, 0, 1, 2, 3. But then you don't get a lot of points, so the graph may not be very smooth. So I try to make this small so I can see a lot more points, so it'll produce that smooth graph that I want. I'm not sure exactly what my x values are going to be, but I'm just going to leave it as -10 to 10 for right now. Okay. So there's what the graph looks like. Let's also look at the table. So if I go to my window, if you go to your table, second graph, notice it gives you your x and y values. So we already came up with, and you will have to, you can type in the t. I'm just going to scroll. So notice this is the first point we came up by hand, and then it gives you all the other values. So we can fill this table in pretty easily. -3, -1/2, -4, and 0. So you want to be able to create a table, you want to be able to look at the graph. Okay. The other thing you want to be able to do is what's called eliminate the parameter. So let's say instead of writing it as a parametric, I want to write it in function mode or rectangular. That means in terms of x and y. So I'm going to eliminate one of my parameters. So y is t over 2. So if I solve this for t, I get 2y equals t. So I know what t is now, so I can go ahead and plug that in to my equation. So instead of x equals t squared minus 4, I'm going to plug that in for t, so I get x equals 4y squared minus 4. And I'm going to solve this for y, since that's how we typically write our equations. And if you look at this graph in function mode, you should get the same graph that's in parametric. Okay, so the next couple we're just going to practice eliminating the parameter. So this one, I always want the equation y equals, so typically I will solve the x equation in terms of t. So x plus 1 over 2 equals t. Here's my y equation. I'm just going to plug it in here. Y equals 1 minus x plus 1 over 2. This is my equation in terms of x and y. Okay, next one. Same thing. So this is really x equals t to the 1/3. So really x cubed would really be t. So if I plug it in here, I have y equals 3 minus x cubed and then squared. And obviously I can simplify that if I want. Okay. The sine and the cosine ones are going to be a little bit different. It just happens instead of t, your third parameter is theta. So you're not going to go ahead and actually solve for theta, but you're going to solve for cosine and sine. So x over 3 is cosine, and y over 4 is sine. Now, what you're going to do for these is with the sine and cosine equations, we're going to use this identity. We know that sine squared of any angle plus cosine squared of that same angle will always be 1. So this is the identity we're going to use. So sine squared is really y squared over 16 plus cosine squared would be x squared over 9 equals 1. That's why we eliminate the parameter with the cosine and the sine theta. Now notice, look at your equation. This is the graph of a circle. Center is 0, 0, y goes up 4, down 4, 3, 3. So this is your graph. Okay, now let's go ahead and also look at this graph on the calculator. Okay, so we're going to do it in parametric mode. So my first equation is 3 cosine of t. Doesn't matter that it's theta, it's just a variable. And my second equation is y equals 4 sine theta, so 4 sine of t. Okay, look at the graph as soon as it gets graphed. So we're going to see our circle. Notice the graph went this direction, and part of the reason why I'm missing this part is because I want to go from 2 pi, but from my previous problem, my t only went from -2 to 3, so I should change this to make sure it goes from 0 to 2 pi. Okay, and let's look at the graph now. So again, same circle, you get the whole thing, but notice it went this direction. The other thing that you need to know about the graph is which direction, or sometimes it'll ask for the orientation, and it graphed this direction. As t gets bigger, this is the way the graph went, so you want to draw an arrow showing the direction the graph went. Okay, last one, same thing, so you've got cosines and sines, so I'm going to go ahead and solve for cosine. I'm going to solve for sine. And again, I'm going to use that identity, sine squared plus cosine squared equals 1. So I'll just do cosine squared plus sine squared equals 1. So this is your equation. And again, this is going to be the graph of an ellipse this time.